What's up, everybody? Hope you all had a good day so far. We are here at week 4. Well, we didn't have Monday lecture because it was President's Day. So just Wednesday today. We're gonna be finishing this thing called decisions. So we're gonna introduce another assignment as well. This is published on the Canvas. So if you want to take a look at these assignments, there's a few of them out. I just want to point out these are due every Wednesday, by the way. Lab week 3, this is describing the stuff we did a week ago. Right now it is week 4. So lab week 3, you'd be describing any activities, if you remember, from last week. Okay, we have another assignment here called taxes. This is pretty much going to exercise your ability to write if statements. You actually don't. You don't have to use if statements. There's some other ways you could do this as project as well. But since we did learn how to write if statements and decisions, it would probably be appropriate. All right. So yeah, here's the taxes assignment. I'm gonna give a quick intro on what it is, and then folks can read this in depth. So I made a couple of slides here. Let's see. I'm gonna go through the slides out of order a bit, but if you take a look at the end of this, it's gonna have some hints. Not really hints. It's more like how the calculations behind work. Okay, so let's go ahead and introduce what this assignment is real quick. And we'll do a few examples on how the behavior is expected. All right. It's almost tax season, by the way, so I figured this isn't appropriate. I think tax season is like in a month or two, so this assignment might help you out. So the goal here is to calculate the federal taxes in 2025. The taxes owed depends on how much money you make. So there's a tax calculator here that I encourage folks to reference. One reason is because it'll help you sanity check your numbers, and another reason is there's going to be some data down here which you'll have to rely on. All right. So yeah, there's a NerdWallet tax calculator. That's what it is from. The goal is to calculate two values given one number. Let's say I'm going back to this calculator here. If I type in like 20K, 20K, this is an input to the program. It represents how much money you make in a year. So if I make 20K in the year 2025, the program should calculate a couple of things. One is the taxable income. Taxable income is the money that the government looks at. So we did make 20K, but the government in this case only looks at 4K and $250. This is the reason is because we're assuming a standard deduction. I think most people take a standard deduction, and in 2025 this is the number for it. This is a number that represents how much money that the government is going to ignore. All right. So this is one of the numbers you want to get, the taxable income. And then using this number, you can also calculate the federal taxes owed. And it turns out to be 425 here, which is a percentage of this number. So yeah, in short, the program is take in one input and produce two outputs. One of the outputs is the taxable income, and the other one is the taxes owed. All right. There's some prerequisites that we should probably talk about. First of all, before coding anything, I highly recommend at least understanding the problem first. Don't try to code out a solution unless you fully understand the problem. So we'll do a few examples on doing it on paper. Actually, I usually do examples on whiteboard, but this time it's going to be on slides. Hopefully people can still follow along on paper. All right, so that's a prerequisite. Understand the problem before before implementing a solution. All right, and make sure you know how to design decision trees. In particular, if statements and maybe some math. All right. Okay, now there's a couple other things that might help you out with the assignment as well. If you take a look at the Canvas project, there's some information here. There's also a video here that will help you visualize how marginalized tax brackets work. Because some people think that income tax is like a straightforward calculation. It's not really a straightforward calculation. There's a lot of steps in between, and those steps depend on which bracket you land in. So I linked the video right here if folks want to take a longer look at this. The video here.
Have you ever heard somebody?
I'm not sure if folks can hear this audio, but if you want to watch this on your own time, you can watch all the way to 1:47, I believe. So all the way around here is where all you gotta watch. And the biggest takeaway from this video, once you get to the minute mark, around the minute mark, they'll talk about how income is distributed amongst certain brackets. Like say, let me pull up an example real quick. Let me scroll through here. Okay. yeah, folks can unmute this later and watch it. But yeah, here, imagine 55K as the input. The 55K would have to fill up some buckets. So in this case, the first bucket is going to be fully filled. The second bucket is going to be fully filled as well. And then there's going to be partially filled in this last bucket. So yeah, this is the biggest takeaway from the video, the distribution amongst brackets. All right, so there you go. The income is now gonna left over into the last bucket. All right, so yeah, in short, the calculation of tax is the sum of all of these buckets. The first bucket is like 9.8K times 10%. So you multiply those. And the second bucket is you multiply these two, the 30K times 12%. That'll give you how much tax you owe there. And then same with the last bucket. You multiply the leftover by 22%. So once you multiply all of them, you can add them and it'll give you the total taxes owed. So that's kind of how this is being calculated right here. Back to the NerdWallet. The NerdWallet calculator. I typed in 20K. All right. There's a standard deduction. Once again, most people take standard deduction, which is a way of lowering your taxable income. It's a way of having the government ignore certain amounts of your money. So there's a standard deduction in 2025. It's 15.75, and then the taxable income is this number. So this number is actually what we use to fill in the buckets. All right, it's not the 20K that goes into the buckets. It's the taxable. So this is going to fill in the buckets, and it looks like only the first bucket got partially filled. I can tell because this number was multiplied by 10% from here. So 4,250 times 10%. This gives you this right here. So from here we can see that 20K only partially fills the first bucket. This is for example, they have 4,250. If you take a look at the brackets down here, we see that they end up in the 10% bracket, meaning that the 4,000 something is going to be taxed at 10%. And they have no leftover money that will leak onto the next buckets. All right, so that's a pretty small calculation right here because it's only one bucket. But let's say we ended up in the second bracket. If I made 50K, let's see. So I'm gonna put in 50K here as an input. 50K, well, first step is take away the standard deduction. This is just to make the assignment a little easier, to take away the standard deduction. And then our taxable income comes out to be like 34K. This number will fill in the buckets. And once the buckets are all filled in, you can add them all up and they turn out to be this number, 3,800 something. All right, so the reason this number came about, it's not really a straightforward calculation. It's like calculating each bucket and then adding them together. So in this case, they're in the second bracket, because with 34K as a taxable income, they're going to end up over here. The 34K is between these two numbers. So they're going to end up paying the full first bucket and a partially filled second bucket. All right, so that's kind of how the calculations here work. Make sure you can do these on paper before coding anything at all. So I'm gonna do a few examples to solidify this, and there's some pictures. And then after the examples, I'll recommend an approach. I recommend a decision tree with several branches. This pretty much means if statements. You don't have to use if statements, but it's gonna make the assignment probably easier. Okay, so let's do some example calculations. Let's say we put 20K as input. This is the first example we saw. So 20K. So 20K here gives us 425. Let's go ahead and talk about how this is derived. So the first part of the problem, if you take a look at the assignment, we need two numbers. So the first step is a pretty straightforward one. It's just subtract something. So the taxable income is a pretty straightforward calculation. So say our gross income is 20K. This is a hard-coded input. In practice, you want to design your program to take any input. But here I'm just going to hard-code 20K. To get the taxable income, for the sake of this assignment, we're assuming that we're single and taking a standard deduction. So in this case, it's just the difference between your annual gross income and the standard deduction. Standard deduction for 2025 is this number. I would recommend in the program defining these as variables or constants. This way in the future you can update your program a little easier. All right, so yeah, our taxable income here is 4,250. This is the first step. Get the taxable income. But then the next part is a little more involved. We have to use this number and fill in buckets. Okay, there are an infinite amount of ways you can represent this solution. I like to visualize it as like a beaker. So imagine, instead of imagining a bunch of buckets, imagine a beaker with some measurements in here. So a beaker is like a glass container that can hold some liquid. You can imagine this. The lines here can represent the brackets. So the first line right here, I titled it B1, which stands for the upper end for being in bracket 1, which ends up in 2025 it's 11,926. And then the second bracket is this third one. There's a few more, by the way. This is an incomplete beaker. It's an incomplete diagram. These numbers come from the IRS, by the way, the irs.gov. So if you look at the IRS tax rate schedule, you can take a look at it, and you see these numbers here in 2025. It's pretty much this. That's where the numbers come from. All right. You can also look at the NerdWallet calculator and scroll down, and they have the same data as well. So here's the calculator. You can scroll down, and yeah, it's the same numbers over here. All right. So that's where the brackets come from. So with the number we got earlier, we converted gross income to taxable income. Now we need to convert taxable income into tax owed. So let's start filling the bucket. All right, we have 4,000 from the previous step. When we fill in this bucket with a beaker, where is the water line going to be? Right? Imagine you're filling it as a liquid. The water line is going to be somewhere below the first bracket, meaning that the first bucket is only going to be partially filled. Okay, so the first bucket being partially filled, this is a pretty straightforward calculation. You just multiply how much money is in there times 10%. Okay, don't worry about this minus 0. This minus 0 will make sense in just a bit. You can ignore this for now. But yeah, taxable income times 10%, because 10% is in the first bracket. And this comes out to be $425. All right, so this is the second. This is the final step. We took in one input. So our input here was 20K, and we produced two outputs. One was this number here, taxable income, and then we used this number to calculate another one, 425 right here. All right, so that's the goal of this assignment. Calculate two numbers from one. Okay, let's go ahead and do a couple more examples. We're gonna dive up the brackets. So here's another kind of random number, 52,743. Let me put it on this over here, 52,743, just a random number. Okay, so you can use this to help sanity check answers. I'm gonna go through the calculations right now. So with 52K something, we would end up having a taxable income of 36,000 something, because we took away the standard deduction. So yeah, this is the first step. This is the easy part. So now we got to use this number to fill in the buckets. So let's go ahead and grab that. Let's go and fill in the bucket. Here is our beaker with 36. Wait, did I make a typo here? 36. Oh, I made a typo. 36,993. Yeah, my bad. So with 36,993, when we fill in this beaker, where is the water line going to be? It's going to be somewhere over here. This means we're going to end up paying the full first bucket and a partially filled second bucket. So it's the sum of two things. The first bucket is full. So once again, don't worry about this minus 0. But since the first bucket is full, there's 11,000 something in there. So that is being multiplied by 10%. But then we have a partially filled second bucket. So the partially filled second bucket, you got to calculate how much money landed in the second bucket. Well, that's the difference. It's the difference between the taxable income and the B1. But B1 is the upper end of the first bracket. So by subtracting them, you get how much money is in here, and then you can multiply that by the percentage. In the second bracket is 12%. So now that we calculate all the brackets, you can sum them up. So add up these two values, and you should get something like 4,264. All right, people getting a sense on how this is gonna go. All right, so yeah, make sure you can do this on paper and fully understand how these subtractions working and stuff. Do people see why I subtracted 0 here? The reason why I subtracted 0 is just to show for the next steps, because the next steps require a subtraction in order to calculate how much money landed in that bucket. All right, so here, let's do one more example, and this should solidify the 100. So with 100K, let's say we put in 100K. So 100K. All right. So first step, take away the standard deduction. So boom, we got the taxable income. All right. Wait, did I make another typo here? Yeah, I made a typo here. My bad. I was copying and pasting from a previous slide. So this should be a different number actually. This should be 84,250, I believe. Let me double check. 4250. Yeah. So first step, take away the standard deduction. Here it ends up being 84,250. Now we need to use this number to fill in the buckets. So with the 84,250, where is the water line going to end? Probably somewhere here in the third bucket, because that's underneath 103 and it's above 48,000. All right, so our water line is going to end up somewhere here, meaning the amount of taxes we owed is the sum of 3 buckets. The first bucket is fully filled. The second bucket is also fully filled. Okay. But real quick, do people see why there's a subtraction right here? Like, why did I do B2 minus B1? Because the difference between these two brackets represent how much money fits in this second bucket. All right? You subtract them to see how much money fits in it. So this is the full bucket. And if we multiply it by 0.12, that would give us how much taxes is owed in this second bucket. All right, so we got 2 full buckets, and then we have a partially filled third bucket. Okay, the third bucket here is partially filled, and you can calculate how much money fits in here by taking the difference between the taxable income and the B2 bracket, the upper end for the B2. All right, so then you can just add all of these 3, sum them up, and you should get this number right here. All right, people getting a sense on these calculations here. Okay, cool. So that's pretty much the assignment. There are some example runs here. These example runs are test cases. When I grade the programs, I'm pretty much running your program with different values every time and checking to see if the output is correct. So here are a few example test cases that only test the first few brackets. It doesn't test all of them, but when I'm grading it, I will be testing all brackets. Okay, so yeah, this is some test cases. The program is expected to take one number as input, one double, like a double variable, and then produce 2 other numbers from it. All right, so yeah, you can use this to double check your answers. I would recommend using the NerdWallet's tax calculator. IRS also has a tool as well, but it's probably a little harder to use and read. And this one's a little more seamless. Okay, I also want to mention something about magic numbers. Part of the rubric requirements, I'm encouraging folks to use named variables or constants instead of magic numbers. So if you're not sure what a magic number is, these are values that appear in your source code with no names or no meaning. So for example, let me look it up. It's kind of like a bad programming practice because it makes things a little harder to read, and it also makes things a little harder to fix. I'll explain in just a bit. But yeah, a magic number, something that appears in your source code. It's a numeric literal, and typically they should have a name. This way the reader knows what's going on in the code. It's not only for the reader too, it's for the writer. So if you were to name certain variables how they were, like you see this beaker here, 11926. By putting B1 here, I'm kind of labeling it. So if you could declare variables or constants in your code, like double B3 is equal to this, and double B2 is equal to this. So declaring and initializing some doubles, this way you can use those variables in your calculation. This is a better programming practice because say in the future, like 2027, how do you update your program? Well, the taxes is going to change every year, the brackets. So if you were to use magic numbers in your code, then when updating the program, you'd have to change so many different numbers. But if you were to name variables and define what the numbers represent, then it will be easy to fix. Because then in a future year, all you have to do is change the initial value for the double B3, B2, and B1. All right. So yeah, that's what the magic numbers are. If you could name the brackets, that would be great. Okay. Feel free to let me know if there's any issues or anything. Hopefully that makes sense. Okay. So that's the assignment right there. That's some hints. There are many ways you can represent a solution for here. I think the easiest way to think about it is a decision tree with several branches. You can imagine something like the last week. Do folks remember last week we did this letter grade calculator? You could imagine it like this. If we're in the first bracket, then calculate it as something. If we're in the second bracket, then do a different calculation. If we're in the third bracket, do a different calculation. So I think this is an easier way to think about it. There's other ways you can as well. But my recommended approach is a bunch of if statements, maybe some else ifs, depending on your style. But yeah, decision tree with several branches that represent each bracket. Right? Okay. Cool. So hopefully people have enough to do the tax calculator now. The whole goal of this is really to see if folks can exercise their if statements. All right, let's move on. So once again, we're still here on talking decisions. We're going to finish this topic today. All right, well, we're going to finish it off with a couple more examples. The first example we'll see is an integer guessing game. This is like it's like a dumbed down version of a gambling game. So we'll do some sort of random number generation here. And then towards the end of class, we'll talk about some special topics like input validation. Input validation is a way of protecting your program from bad input. And then we'll finally end off class on this other special topic, switch cases. As we'll see in programming, there are an infinite amount of ways to represent the same exact solution. Switch cases is another way of representing certain if statements. And they're way faster. They're way more efficient. So we'll talk about this as well. Okay. But yeah, let's go ahead and jump into this application. I wanted to do a demo of a integer guessing game. This is going to help us learn about random number generation. It's also going to exercise our if statements. And we're also going to get a sneak peek into loops. We haven't covered loops yet, but we'll get a sneak peek. And next week we'll cover loops more. All right. So yeah, for this guessing game, let's say we wanted to write like a game or something. Imagine like a really dumb gambling game. Like, hey, guess a number. If you get it right, then victory. If you get it wrong, then you lose. So something really small. So yeah, first step, we need to find a way to generate a random number. There's many ways you can do this in Java. Let me set folks up real quick. So I'm gonna create a file here. Let me restart everything. Okay, I'm just gonna restart everything. So let me create a file here. I'm gonna call it guessing game. Okay. Guessing game. Let me go ahead and set up the boilerplate. Main. Okay. Let me also set up my terminal. I need a cd into examples. Okay, great. Let me do an ls. I should see it. Guessing game. Perfect. Okay, first step, we should find a way to generate a random number. There are many ways you can do this in Java. I'm going to show a couple ways. You could Google up something like Java random, and if you click on the primary documentation here, it's going to introduce you to a class called random. This is code that lives somewhere else. So there's some documentation here. I'll explain what this documentation means. But we'll also see that this recommends another method. This sentence right here, it says, hey, here's another way on generating random numbers. This is another library. It comes from math.random. Once again, as you'll see in programming, there's like an infinite amount of ways to do something. If we were to use the math.random, how we use this is by calling a method. So it's kind of like here. So let me run the J shell real quick. Once again, the J shell this is not really representing my program right now. I'm just using it to test one line so people know what it does. And the line I'm going to test is math.random. Okay, so this is a Java method. There's a class called math, and okay, so a class is like a code that lives somewhere else. It's called math, and then it has a method called random. This returns some sort of value. So if I press enter, you see how it gives like a random decimal here. I could run it again. So I'm running it, and now I get a different decimal, slightly different. Let me run it again, and then yeah, there's another decimal. So yeah, this is one way you can do it. We're using the math.random. It's a little simpler to use. It's not as powerful, but I wanted to introduce another one. The reason why is because with our design, we're trying to generate a random number and have the user guess it. But it would be pretty hard to guess this number here. You know what I mean? Like, hey user, try to guess a number between something. And this is gonna be really hard to guess. You could convert this to an integer by doing some more math. You know what I mean? Like you could multiply this by like 100, by like 10 or 100, and this will kind of change the decimal, and then you could truncate. You could ignore the decimals later. You could do that, but it's probably going to be easier if we use this other method from the random class. There's this class called random, and it has a bunch of functions, methods here, that start with next. So they got a method called next double, next float, next int. They have another one called next int, the same thing but with a additional thing. So I would recommend using this one because there's a lot more power. How we use this is first, I don't think this is included in the native Java. Let me test it real quick. So if I were to use this, so here I'm going to type in some code and explain it later. This will make more sense towards the end of the semester, actually, when we talk about object-oriented programming. But let me just test something real quick. Let me see if this works. So random. So here I'm kind of like stating a variable type. Not really. It's kind of like saying, let me call this number generator. All right, so this line, I'm doing a bit of object-oriented programming right now. It's kind of a more advanced topic, object-oriented programming. For now, you can think of this as I'm declaring a variable. Like, you know how we declared variables as like double num, and then we said, oh, this is equal to something. So it's going to be very similar. I'm declaring a type random, and I'm naming it number generator. This name doesn't really matter. It's just the name of an object. Okay, but I'm going to initialize this to something called new random. And let me actually just test this line first, because I want to see if this is already included in the new Java. So let me save and then run it. Compile. So compile. Okay, cool. It did compile. in previous versions of Java, you'd have to include something. You'd have to do something like let me see real quick. You'd have to import java.util.random. So yeah, in the previous version of Java, they didn't include this by default. So you have to include libraries on explicitly. So if you're working with textbooks or older material, you'll see imports. This is pretty much grabbing code from somewhere else and kind of pasting it here. It's saying, hey, I want to use code that someone else made. All right, so yeah, you would have to do this in previous versions, but not anymore. Okay, so real quick, what is this doing? Well, first of all, I'm doing a bit of object-oriented programming. This is something we'll cover towards the end of the semester. For now, you can think of this as I'm declaring an object. Okay, the object is called number generator. Okay, this name doesn't matter. You can name it whatever you want. So the object is called number generator, and it comes from the random class. Okay, the random class is like a cookie cutter. So a cookie cutter here is random, and then the actual cookie is number generator. All right, and then on the right, this is just saying make a new one. So yeah, that's, you don't have to worry about it too much for now. Just think of it as I'm declaring a variable and I'm going to use it. So one way we can use the number generator is by using this method down here called int. Next int, I mean. There's a method called next int. It returns an integer. The description is it returns the next pseudo-random number. Okay, we'll talk about what pseudo-random means. But let's see. Let's go ahead and test it. So this function, method, returns an integer. So the way we call it for now is by using the object's name and then the name of the method, which is next int. Okay, so there we go. I'm calling a method. This method returns a integer. It returns an integer right here, meaning it might be useful to store it. In this case, it is useful because we're planning on using that number later. Okay, so I'm gonna go ahead and store it by setting on the left side equal to like int num or something. Okay, int num. So this line is generating a random integer and is storing it into this num variable. All right, it goes right to the left. That's how the order goes. And then let me go ahead and, oh, I should probably output this. So I'm gonna go ahead and output it to, so I can sanity check this number. Okay, I'm gonna use the system actually. You can use the IO one, but I'm gonna use the system.out because it has this printf function, which is more powerful. The printf function allows us to format in the same string. The number is then %d. %d, this is saying there's going to be a digit here, and it's going to be substituted by num right here. All right, so let me go ahead and test this Java guessing game. Okay, cool. I just ran it, and then now the output is this number. Let me run it again, and there you go. It's a different number. Try it again, and boom, different number. Okay, people kind of getting a sense on what's happening. Okay, you don't have to use the system.out.print. There's another way. People are probably more familiar with the print line right here. Print line, which is the same as number is plus, and then string. I'm adding strings together. I know the right side is not a string, but since the left one is, it's going to add them both as strings. So both of these do the same. Oh, I need to put a new line at the first print statement. So here, let me do a new line. So /n. There it is, and then now it should print on multiple lines. There you go. Yeah, I'm just showing a couple ways on printing. Okay. So we successfully generated a random number, which is different every time. Okay. Our goal here is to write a guessing game. This is kind of hard for folks to guess right now. The numbers, these are pretty large magnitude numbers. It's going to be pretty hard for the user to guess. So sometimes it's necessary to restrict a range of the random numbers. And with this method, we are able to use the same exact method, but with an argument inside of it. Oh, so here we used next int, but there's another one here. You see how this is the same, but it has an additional argument in here? An argument is input to a function. It tells the function how to work. So in this case, if we were to use the next int method and provide it some sort of integer, the behavior of the method will be a little different. In this case, the integer represents the upper bound, and it would automatically do the lower bound of 0 here. So you could put a number in here. If I put 10 as an argument, this should constrict. So let me go ahead and test it. It could, yeah, see, it's restricting it. So now we're generating a random number between 0 and 10. Okay, so I'm running it again. And yes, it's different. Sometimes you'll get the same in a row because it's based on luck. Let me see if I get the same numbers in a row. I'm gonna keep running it. Well, I have a 1 in 10 chance of getting the same number in a row. So I'm just gonna run this a couple more times. Okay, cool, yeah. I was making sure it's truly random. With truly random, you should be getting same numbers sometimes. Okay. Cool, so we just used this method called nextInt. How this works is it returns a number between 0 and the specified value. Exclusive. So exclusive means it doesn't include the number, meaning that it's never going to be 10. So it's the range here is between 0 and 9 because 10 is exclusive. 10 is not included. All right. Okay, cool. So we just generate a random number between 0 and 9 inclusive. Let's go ahead and do the rest of this guessing game. We want the user to guess the number. So now it's probably appropriate to handle input. And then we could do a decision tree later. This print statement was really just for sanity checking. So I'm going to delete it. Delete it. That was just there to visualize what the random is doing. Okay, let me go handle input. I'm going to ask the user to guess a number. So I'm going to use IO actually. IO.print print guess a number between 0 and 9. Okay, so let me prompt the user. Let me go ahead and take input. So input, let's see. I'm going to go io.readLine. Okay, once again, this returns a string. Whatever the user types in, it returns a string. So I'm going to go ahead and store it into something called user input. Okay. And it might be necessary to convert this to a number. This way we can do numeric operations. You actually don't need to convert it to a number, but I'm going to do it for learning purposes. So this is a number. Let me go ahead and convert it to an integer. So I'm going to go ahead and declare an integer. I'll call it guess because this is what they guessed. And then I'm going to set it equal to the conversion of user input. So I'll put user input here and then convert it to an integer. Okay. Cool. You've seen me use this before, the integer.parseInt. And here, let me just sanity check this real quick. I'm gonna sanity check by printing what the guess is. Dot out dot print. You guessed some number, and then guess right here. Okay, cool. I'm just gonna sanity check the input, making sure it's taking it in correctly. So let's go 5. 5, enter, and it says you guessed 5. Let me test it again. 8. You guessed 8. Okay, cool. Just testing the input and the conversions. Great. So now that we had the user make a guess, we can go ahead and use this integer value to branch off into different scenarios. You can think of this guessing game as like a win-lose scenario. You're programming random numbers and having them either win or lose. So we should probably make a decision tree. Like if they got it correct, then do something. If they got it wrong, then do something else. So here, I'm gonna go ahead and write a decision tree. If, and then I'm gonna do an else over here, because with a guess, you can either get it, or you can either get it wrong or correct. The order doesn't matter too much here, but for the first branch, I'm gonna represent the incorrect one. So let's say the first branch represents the scenario where they got it incorrect. Incorrect. And then let's say this else statement is catching the correct over here. Correct. Okay, so if we set up the branches here, what would the condition be for this first one? A condition, well, what do we put inside of these parentheses? Well, we need to represent when they don't equal each other. So if you do, you might remember that there's not equals. That this is an operator. That's it's only true if they don't match. Okay, so people think this is saying, it's saying if both sides don't match, then the whole thing is true. So in this case, if it's true, they get it incorrect. All right, let me go and test it. So let me go ahead and compile and run it. And then, okay, guess a number between 0 and 9. Let me guess 5. And it says incorrect. Okay, so it wasn't 5. It's let me test it again. Actually, if I run this over and over again, it's going to say 5 at some point, because it's going to generate 5 with a 1/10 chance. So let me just keep trying this until I get it correct. Okay, run it again. Incorrect. I got a 1 in 10 chance of this being correct. Let me keep running this. Okay, cool. I finally got it correct. All right. So people seeing what's happening here on this round. It generated 5. I guessed 5, and since both sides were the same, this is false. So we ended up printing correct. All right. Okay. So yeah, I just kind of did the reverse logic. I mean, you can actually reverse the logic if you wanted to. It would be a good exercise, a lab activity to play around with this. All right. So there we go. We just finished the application. All right. But I wanted to give a quick sneak peek into loops because this program is arguably flawed. Mainly because we only get one attempt at guessing it, and if we get it wrong, we would have to run the program again. And running the program again would generate a new number. So if we wanted to upgrade the program and maybe give the user some more attempts, like let's say we want to give them an infinite amount of attempts. So have them try over and over again until they get it correct. We would have to introduce loops. In particular, we would probably have to loop a piece of this code. This over here, we'd probably have to loop this. Not everything, not the whole code. Because if we loop the whole code, it's gonna still generate a new number. All right, we want to generate one number and give the user an unlimited amount of guesses until they get it correct. Okay, so here's a cool part. We only need to make a couple changes. Okay, so here, check it out. I'm gonna delete this else real quick because I'm gonna bring it out in a different way later. So I'm gonna remove this else because I'm representing the incorrect. Check it out. You can actually loop this whole thing here by converting this if to a while. Okay, once again, this is a sneak peek to next week. We're gonna jump into while loops a little more in depth. But a while loop works kind of like an if statement. It checks if the condition is true, and if it is true, it's going to perform the statements. And then it's gonna loop. So it's gonna do the statements and check the condition again. Is this still true? If it's still true, we're gonna do the loop. All right, and then at some point, the condition will probably be false, meaning that the loop will terminate and exit to here, which is the rest of the program. So for the rest of the program, I'm just gonna do a print statement, like thank you for playing or something. Thank you for playing. So check it out. I'm gonna go ahead and run it real quick, and folks can see what might happen. So I'm gonna go ahead and run it. There it is. It says guess a number. So I'm stuck on this line. Let me type in 5, and then enter. And check it out. I'm getting a bunch of incorrect here. My terminal is spamming this output. I have like 1 million lines here by now. So it looks like the program crashed. You could consider it a crash. I consider it a infinite loop. An infinite loop meaning it's constantly going and it's never stopping. So one way you could pull the plug on a program is by pressing Control C, I think, on some systems. So press Control C. This should quit. It's like a pulling the plug though. It's not really gracefully quitting the program. Because if we gracefully quit the program, it should have printed "Thank you for playing," but it didn't. So yeah, Control C. All right, so Control C is to quit. Hold on, let me do something real quick. Okay, just had to adjust something. So we have an infinite while loop here. The reason why is because this condition is always true. We typed in 5. 5 does not equal whatever number, so this is true, but it never becomes false because we never have more attempts. So if we wanted to fix this infinite loop, we would have to find a way to make this true at some point. I mean false at some point, and we could do that by giving them more attempts. So check it out. I can actually just copy this over. Copy these 3 lines because we have to loop these again. So I'm gonna copy and then paste down here. And let me indent. So I'm indenting once again because when we see scopes, these curly braces, we're declaring like a local block. And by indenting inside of it, it kind of helps the reader skim your code a little faster. Okay, so let me go ahead and test this now. Oh, by the way, this copy and paste thing, I'm actually redeclaring the same variables. I'm redeclaring the same variable in a different scope, so it's actually different. So I'm going to remove this string over here. So this way I'm reusing our pre-declared one. And the same with the guess here. I'm going to remove that int because we already declared it up here. If we redeclare it inside of another scope, it's gonna make like a copy, and it's not really gonna work with the original one. Okay, so let me go and test this real quick. So Java, and okay, cool. So we're here. Guess a number. Let me go ahead and put like 5 here. 5. Incorrect. So here, let me trace this. So this condition became true. So we perform all the things in here. It says incorrect. Now it's printing guess another number. And now we're waiting for another input. So we'll type in another input. It's going to finish this line, and then it's going to convert the string to an integer. And then we're going to check the condition again. All right. So let me type in 6. Type in 6. And it turns out 6 is incorrect as well. 6 does not equal the whatever number, so this is true. So let me keep guessing. Let me go 7. And yeah, it looks like 7 finally terminated the loop, because then this condition became false. 7 is equal to 7, so this is false, and the loop terminates and goes down to the over here, the rest of the program. All right, so yeah, this is a sneak peek into while loops. People cool with this so far? Okay, cool. Next week we're going to extend this game into some sort of like a roulette. It's just a small gambling game. Like guess a number. If you guess it correctly, then you win some money. If you get it incorrectly, then your bankroll decreases or whatever. So we'll do that next week in the loops. If you want some head start on this, you could look at the Java material. Where's it at? It's over here. The recommended readings. Let's see. Let me pull up the weekly schedule. Next week we're going to be talking about loops. Week 5. So if you want a head start, there's 2.1 and 2.2. That's over here. So 2.1, 2.2. Let me pull it up. 2.1 and 2.2. Yeah, these first two parts. Highly recommend looking through it before the next lecture. Okay. Okay, what else? All right. I wanted to talk about how fragile programs are, especially during input. It's very easy to break a lot of programs during input. So we can have runtime errors and exceptions. We can have logical errors. These are errors that happen after the compiler. So the compiler won't catch these errors. It's really up to the human to catch them. Some examples of bad behavior that might happen is if we run the program and type in like some strings instead. So here, let me run the program again. So check it out. So it says guess a number between 0 and 9. So I'm stuck on this line right here. If I type in like 0 as a string, something weird might happen. Well, first of all, this line is going to succeed. User input will become a string 0. But then this next line is going to attempt to convert this to a number, an integer. And we're going to get a runtime exception. Okay, a runtime exception, this is not the compiler. All right, the compiler happens when it's translating the program. But this is happening during runtime. So yeah, you see how fragile programs are? Like even if we were to get it correct, like 5 right here, if we were to type in a valid value and still here type in 0, where is it gonna fail? This is a good exam question, kind of. Let's see. So we're stuck here. Okay, it's waiting for input. When I type in 0 and enter, this line should succeed. User input is going to become the string that we typed in. And then maybe we're going to fail here. So yeah, so we failed there. The program had an exception, so it quit. It quit the program, pulled the plug, and didn't even get a chance to go to the next statements. So yeah, programs are really fragile. It's really easy to break them during input. So sometimes you want to validate input. One technique is called bounds checking. Bounds checking means to check to see if the number is within a certain range. Like for example, if I were to run the program again and type in like negative 20, negative 40, Well, there's not gonna be any errors here. See, I pressed enter. There's no errors because -40 is able to convert to a number, but it might be useful to do some bounds checking. Like maybe you could tell the user like, oh, that number is outside of the range. Try again. You know what I mean? Like you could put some conditions in here and say something like if something, then maybe you could print like out of bounds. Out of bounds, right? So what's the condition for a number being out of bounds? Well, in this case, it's out of bounds if it's not within this range. So if it's less than 0, then it's out of bounds. Or if it's outside of the 9, if it's greater than 9. So this is a technique called bounds checking. And if I run the program again, like -50, the oh wait, what happened here? Did I save it? Okay, it should have said out of bounds actually. Let me run this program again. I'm gonna quit this program. Control C will terminate it. Control C. Let me save it again. Okay, guess a number. Let's go -50. Oh, you know what? I have a logical error here. Hopefully people saw what I did here. I ended up comparing the number instead of the guess. So this condition is never true. It's never true because our number was generated between 0 and 9. I meant to compare the guess. So let me change this to guess. Okay. Let me quit this program again, Control C, and then run the program. Okay, so now we're doing bounds checking. -50. It says, oh, out of bounds. Incorrect. Guess another one. Let's go like 2 million. Out of bounds. Incorrect. Let's guess 5. Okay, 5, it only prints incorrect because it's not out of bounds. All right. So this is a way of bounds checking. Unfortunately, it still doesn't protect us from conversion exceptions. Like if I type in 0 as a string, or if I type in like IDK, any sort of string that can't convert, I'm still going to get an exception. So yeah, our bounds checking is appropriate for if it was a valid value, but it's in a different range. If you wanted to protect your program from those exceptions that we saw earlier, like did they type in an actual number, you'd have to do something called input validation. So we're not going to cover input validation today because I think we need to talk about exception handling. This is a advanced topic which we'll talk about towards the end of the semester. But if you did want to look into input validation, I have a couple more slides too. There's a couple techniques you can do. You could handle input validation with the scanner. If you did the reading, you should be familiar with the scanner by now. You could use if statements to check if it's a number. Like here, this line of code is saying, did the user type in an actual number? That's what it's saying. If they didn't type in an actual number, then maybe the program will branch off into like an error message. The error message says, hey, try again. That's not a valid number. And there's a couple steps here that's going to get rid of the garbage, and then we can take input again. All right, so this is a technique. It uses the scanner class. The scanner is very powerful. It's got a lot of access to exception handling and error messages and all of that. So yeah, you could use the scanner, or a more advanced topic, you could look at exception handling too. Once again, we'll cover this at the end of the semester. We'll talk about try catch. Try catch is another technique. But basically, how a try catch works is if any of the statements fail in the scope. So we have a try scope right here, an isolated block. If any of these statements errors out or has an exception, then it's going to be caught in another scope. This is a catch scope. So you can have many exceptions, but they will leak into down here, and then yeah, it'll catch it and give you another try, hopefully. All right, so in this class, I'm not gonna try to break your program by typing in numbers. I mean, by typing in strings. Like for example, this tax calculator. The tax calculator over here. I do have some hidden test cases. Hidden test cases are example runs that you won't see until I grade them. Well, when I grade the programs, I'm running your program 14 different times with 14 different inputs. And I want to guarantee folks that I'm not going to try to break your program by typing in a string. So you can assume that there will be legal numbers being typed into your program. All right, so you don't have to worry about input validation yet. But if you're writing very robust programs, if you're writing programs that you don't want to fail, then it would be appropriate to do input validation. All right, and just kind of motivating this topic a bit. In the older days of the internet, there was a cyber attack, a technique. I mean, there was a technique called SQL injection. So it's not really just the old days of the internet. It's still around here. SQL is a different language, by the way. It's a language that allows you to manage databases. A lot of websites use this type of language, especially for the big companies. So there was a technique called SQL injection, which takes advantage of programs that didn't validate input. So if a program didn't validate input, people would be able to inject code into certain websites. Like you can imagine here, I'm gonna go on Google actually. Let me go on google.com and let me pretend to sign in. Okay. Google has good security, I think, but in some websites and in some badly written applications, you can imagine that this is like input right here. So the Google is waiting for input, and if I type something in here, like I'm gonna pretend to write SQL code. So let's say I wrote some SQL code that says like drop row 3 or something. So this is not actual SQL code, but hopefully people see what I'm trying to do here. I'm putting in like a hypothetical command, and if the application doesn't validate it, something bad might happen. In here, I'm trying to delete some information. I forget the actual command to delete information, but in some websites you could inject SQL and put in commands to break their program. All right, so that's what I mean by writing robust programs. There can be programs are very fragile, especially with input. All right. Okay, let's move on. So we just finished this guessing game. The whole point of it was to talk about random number generation, talk about if statements, and give a sneak peek into a loop. Okay, we'll do more loops next week though. But for now, let's go ahead and continue the rest and we'll be done. So I wanted to introduce this control flow called a switch case. As we'll see in programming, there are a lot of different ways to do the same exact thing. Switch cases is another way of representing some if statements. This is good for representing if statements that check for equality. Okay, so let me just do one example without switch cases, and then I'm going to convert it to something with switch cases. Right, so say we were writing like a video game menu, or not video game menu. It could be like an application where it says, "Hey, press 1 to do this. Press 2 to do this. Press 3 to do this. Press 4 to quit." Right? So imagine we got like some choices, and we want to have different cases for each choice. So let me do a hypothetical program real quick. I want to call this one main menu. So let me call this one main menu.java. Okay, let me go ahead and set up this main here. So the hypothetical scenario is we're making a menu with a few options, and the user can choose which option to do. Think of it like a story, like a visual novel. For folks who have done like visual novels, you have a dialogue, and you get to choose what dialogue to talk to. So I'm gonna do some options here, like I'll say like option one. Let's say one is I don't know, for a video game scenario, the first option is usually continue game or whatever. So continue game, and then the next option is usually like start new game or something. Start new game. And then third one is usually like settings. 3 is settings, and then 4, the last option is usually quit. So here's 4 print statements that just shows them options. And say we want the user to choose something. So I'm gonna go ahead and prompt the user to make a choice. Choose an option. And let me go ahead and take some input. So I'm gonna go ahead and take input. I'll take it as a string. So I'll store it as a string. And then I'm gonna go ahead and convert it to a number. There's actually no need to convert it to a number, but I'm doing it so we're aware of how to do it. So string user input, let me go ahead and convert it. So I'll convert it and store it into a variable called choice. And this is going to be equal to the conversion. So I'm taking the user input and then converting it with this integer.parseInt. Okay, I actually typed too much. I should probably test it right now. Let me test this. So Java main menu dot Java. Okay, cool. So we have 4 print statements. We have 4 options. The user, let me type in like 3. So with 3, the program quits because we didn't implement anything else. But you see what I'm trying to put here though? We're trying to now make a decision off this choice. So you can imagine there's probably going to be a decision tree with 4 branches. So you can imagine as like if, else if, and then another else if, and another one. A decision tree with 4 branches where we're comparing the choice. So here we're comparing for equality, whether or not choice is equal to 1, whether or not it's equal to 2, 3, and then 4. And for the sake of simplicity, I'm just going to put some print statements in each of these branches. Like if they chose 1, then I'm just going to do a print statement. In practice, it would actually activate something. It would activate like another method that would actually continue the game. But I'm just gonna do a print statement. So let's say continuing ... And then second option, this is start new game. So starting new game. And then let me do another one. This is settings. Changing settings. And then the last option is quit. Oh, hold up. I need to fix my spaces. Okay, cool. I was making sure it was there. So here they quit. I'm just gonna say bye-bye. Okay, cool. So we made a decision tree with 4 branches. And all of the branches are really just comparing for equality. So this is gonna work, I think. So Java main menu, and then choose an option. So let me press 1, enter, and it says continuing. Great, great. Once again, in practice, where the print statement is gonna be something else, it's gonna actually do a method that will boot something up. Let me keep testing it. So let's go number 2. To enter, starting new game, looks good. Let me do it again. I'm pressing up on the keyboard, by the way, if folks weren't aware. Up on the keyboard will bring you through the history of your terminal commands. So let's try 3, changing settings, looks good. And finally, let's test the last branch, 4. Bye-bye. Okay, cool. Cool, so we represented a decision tree with 4 branches, but I wanna repeat that. Since we're comparing for equality, right? You see what I mean by equality, where we're checking to see if both sides are equal. Since we're doing that, there's actually a more efficient approach we could do. See, check it out. See, if I run the program again and type in 4, okay, it is instant. There's actually a more efficient approach to this. When I typed in 4, there's some decisions being made. There's some redundant checks being made. I typed in 4, so choice becomes 4, and then now it's gonna go here. It's gonna say, hey, is choice equal to 1? No, it's not. So it's gonna check the next one. Is it equal to 2? No, it's not. Is it equal to 3? No, it's not. Is it equal to 4? Yes, it is. So it might seem like it's necessary to go through all of these, but it's possible to implement another control flow that just jumps straight to the choice. Okay, for this example, it's kind of hard to see efficiency because of how fast these computations are. But when we start looping computations, the efficiency will come out a little better. All right. Well, yeah. Right now, these are some really fast, small programs, so it's really hard to see efficiency. Anyways, another way we could represent this tree is with a switch case. This is a way more efficient because when it compiles down to machine code or assembly, it does something called jumps. All right, here, I'll explain this right now. Okay, so I'm gonna comment out this tree. Okay, well, once again, you can comment it by pressing Control /. So I'm commenting out the tree. Another way we could represent this is with a switch case. So in Java, that looks like this right here. It's a switch based off of some value. And then inside of the scope are going to contain cases. All right? I do want to repeat that a value goes into these parentheses right here. A value, not a condition. A condition is something that can be true or false. But with a switch case, we could put a value in here. So in this case, I'm going to put choice. All right? Choice is not a Boolean. It's not true or false. It's just the integer. The switch case takes the value and it'll jump to certain locations within the scope. That's what's cool about the switches. If the choice were to be 1, it would jump to case 1 right here. Okay, and if the choice were case 2, it would jump straight down here. And same with the other ones right here. Okay, so I'm just setting up some cases here. Let me go ahead and get the print statements in here. So this is continuing, and then this one is starting new game, changing settings, and finally bye-bye. Okay, let me just test this real quick. I'm gonna run this Java. Okay, cool. Let me type in 4. Okay, I typed in 4. I said bye-bye. How this works is choice became 4. 4 goes into here. So this choice gets substituted by a 4. And there's going to be a jump happening. The jump goes straight to case 4. It doesn't say, hey, is choice equal to 1? Is it equal to 2, 3? No, it doesn't do any of that. It literally just jumps straight to 4 and performs this. So it's really efficient. And if you want some more detail on this, there's a whole class dedicated to this actually. It's called a CS-12. I'm not going to jump into this too much in class, but there's something called a jump table. Basically, when you compile the program, this is human readable. This is meant for humans to read. When you compile it, like when I typed in Java main menu Java, there's a compilation in between, meaning that it's going to take this human readable code and convert it to something else. It's basically converting it to a branch table, which is very efficient. It's you could take a look at this later. It requires a bit of understanding machine code or assembly. I mean, but yeah, for now, just think of it as it's very efficient. It's able to jump instead of compare. But the caveat with this control flow is we get a leak down effect if we go into certain cases here. Like let me run the program again. If I type in 1, 1 should bring us into this first case, but here it's going to print everything. You see what I mean? It printed continuing, so that did work. But then it leaked down and start new game, changing settings, bye-bye. Right, it should have only printed one thing. So one of the caveats about this efficient control flow is this leak down behavior. You'll see in practice that they're typically doing a break after every case. In Java, there's a keyword called break. Break means to quit the current scope. You might remember from last week, the scope defines like an isolated block of code. So the most recent scope, or the most inner scope to this break, is these 2 curly braces. So by saying break, it's saying go to the end of the curly brace. All right, let me go ahead and do the other ones. Okay, I actually don't need one on case 4, but I'll put it there because I'm gonna put another case after actually. So check it out, So by breaking, it's no longer gonna do that trickle down effect. If I do 1 here, it properly prints continuing because we print this, it leaks down to the next statement, which will quit the scope. The end of the scope is over here. Okay, yeah, there's nothing else further down in the program. Okay. You'll also see if you do a bit more reading, there's something called a default case. A default case is it's like an else statement. It's like a catch-all. If any of the earlier ones were false, or if the choice doesn't exist, it's going to jump to the default. That's what I meant. So it's like a safety thing. Like let's say they type in like 500. 500 is not a choice, so you might want to give them an error message, like not an option. So I'm going to do default case. It's like an else statement. Let me go ahead and test this. So pretend I typed it in like 50. Okay, 50 is not valid. So since the case doesn't exist, 1, 2, 3, 4, there's no case 50. So it's not an option. All right. If you for some reason wanted to do a case 50, you could put the case 50 wherever you want. The order doesn't matter, I think. So if you for some reason wanted a case 50, like say 50 was a cheat code. Say 50 was a activating cheat code or something. And then let me do a break here. Right, for some reason, this will work again. So Java, we got 4 options, but if we type in 50, then we get like a secret. The secret here is activating cheat code or whatever. All right, so people getting a sense on this. Okay, I'm gonna remove that though. All right, so yeah, that's a switch case. It's another way of representing certain if statements. In particular, if statements that compare for equality. Okay, so it's only working because the choice must be a value that we're checking to see if it's equal to certain cases. So yeah, this decision tree is the same as this switch case. In this scenario, the switch case is a lot faster. Okay, you also see this in practice if you do video game programming. Like if you ever game on the keyboard, there's the keys, WASD. Those are those are keys that help you move up, down, left, right. So you can imagine like a case left arrow would move your character left. A case right arrow would move your character right. A case up arrow, and so on. Yeah, you'll see this in practice. Okay. People cool with switch cases for now? Okay, cool. All right, so that's about it for today. It looks like we finally covered this topic, decisions. It took us a couple weeks, but we did miss out on a day, the President's Day on Monday. But we're still on schedule. Well, we're not behind at all. We're totally on schedule. Next week, we'll go over loops. So I don't have any slides for it yet, but you should take a quick sneak peek in it. Next week is week 5. We'll be talking about the while loop, which is 2.1, 2.2. So that's over here. 2.1. 2.1 is going to talk about, it's going to motivate what loops are useful for. And then this next part will talk about while loops. It's also probably going to talk about for loops too. Let me check. No, okay, it looks like it's only while loops. Okay, cool. Yeah, so if folks could take a look through those first 2 sections, that would be great. This is actually probably the harder part of a lot of intro to programming classes, not just Java. Folks, it's really easy to fall behind in these next 2 weeks. These next 2 weeks, we're finally going to be able to repeat code, meaning we can design solutions that require repetition in between. I think this is the challenging part of a lot of classes because we jump into something called algorithmic thinking. Algorithmic thinking is one of the learning curves of a programming class. So algorithmic thinking is a way of kind of like organizing your thoughts. Let me see, is there a Wikipedia on this? Let me check. Computational thinking. Yeah, this is another synonym. So this is like the hard part of a lot of programming classes. You can think of it as organizing your thoughts into a way of representing a solution. But the solution has to be able to like represent some computational steps, meaning like statements. Like in Java, there's statements. So organizing your thoughts into a series of statements is probably the hard part here. So yeah, for the next couple of weeks, it's really easy to fall behind. I highly recommend going through the readings and trying out every single exercise. We're gonna see loops for forever, for the rest of the class after next week. All right. So yeah, it's a pretty dense chapter, as you saw earlier. There's a lot of things. It's a pretty big one. Okay. So yeah, loops next week. Let's conclude. So today, in the beginning of class, we gave some hints on the project. The hints are really the hints are really to help people do it on paper. So if you know how to replicate the calculations on like a whiteboard or on a paper, then you're probably ready to do the tax calculator. But please don't type anything until you fully understand the problem. All right, and you can replicate it on hand. Okay, and yeah, I recommend decision tree. So yeah, we did that in the beginning of class, and we finally covered the rest of the chapter. Okay, that's it for today, folks. It looks like we're gonna end. Oh, we're gonna end like 15 minutes early. Okay, cool. Great. Have a great day, everybody. Bye bye.